So hi everybody and welcome back. This is our C++ tutorial series for absolute beginners. This is video 341 and in this video we continue with our move constructor. So we figured out the move constructor here will be called, and we have now see how this move constructor, what does this move constructor do step by step. First of all, we pass it here. And we can see here's the parameter list. And again, when we talk about constructors, the parameter list is very important because you distinguish with the parameter list these constructors. And the order of the parameter is also a little bit important because you should start with an $ampersand for the move constructor. Of course, it can you can do something like here. You can add a const or something in front, but the first parameter must here for the copy, for example, $ampersand. For the move, what we are talking now, $ampersand. All right, so we have understand the parameter list is important. Next step, what we are doing here again, we have here a variable. We are creating here a variable now. Interesting. And how does this happen now here? Let's figure this out. Again, we repeat. We creating here a temporary object, unnamed, an R value. And then it jumps here to the struct. It checks with constructor it can bind. It jumps here now. It selects here now our move constructor because it can bind to an R value. This one here can bind to an R value. So far we understand everything, I hope. And now the question is, okay, this object will bind here to this here. What happens here actually in this parameter list? It's a little bit, confusing, but careful. What happens here? The answer is we are creating, we are binding this past temporary object here, and binding means we are accessing it, right? But here is something interesting, this O. What makes this named variable O here? What means that here? The answer is we are binding it to an R value, but we are creating a named variable here at the same time. And the question is why we are creating this one. The answer is because we want to access it and do something with this past object. And here, this one is all time the tricky part later. What happens here? A little bit when we talk about value categories. And this is here careful and tricky. And you should not make this mistake. First of all, we pass in an R value, okay, because it's temporarily unnamed, and we cannot access it later. And this type of a temporary objects are most time an R value, and this is a R value reference. This double ampersand here is an R value reference, right? But when you bind it to an variable like we do here, because we pass in, we bind it with this O, then we have here a named variable. And when you watch now this together, this type here, I mean the value category here is what? It is an L value, but we have what kind of type here? An R value type. This is not an R, so an R value reference type. And this is confusing because normally many see this one, and me too. And I say, this is an R value reference type. It will be probably an R value, but careful. That means only when you pass something in. So from this step here, which is a temporarily unnamed object, an R value, you pass it in. And this parameter says only I expect an R value. But what it is creating here with this O is an L value. That will be very important. That's why I repeated this again. And all time use the thumb rule when you see a named variable, and in this case we have the variable named O, then it is all time an L value. Doesn't matter what reference type we have here, because this is easy thumb rule, so just use it. Most time it will work. Okay, let's continue here a little bit. So what is this here? We have here a no except specifier. Okay, question, what does this no except specifier do here in our move constructor? The answer is, in this case, it's a special requirement. And why it is a requirement? Because first of all, no except means in general you should not, it's talking here to the compiler. The compiler should not throw here an exception. And what does this mean? The compiler should not an exception. Normally, the compiler will try to execute a move, also will try to make a move. Also use the move constructor and try to move an object from one place to another place. But while it is trying to use that, there could happen any exception, right? That can happen all time. And when an exception happens while the compiler is trying to move an object, can cause what? An exception means most time, not all time, depends on how you handle this exception, but most time it means compiler, stop here, don't do, and go out. And in this case, we have this implementation no except, and that will be used in the standard library. This no except here with the move constructor is all time, most time, let's say not all time, most time used in the standard library. That means they are saying to the compiler, wait compiler, for this constructor, if something happens, we don't want that you interrupt the whole process. Instead, you just interrupt this move here, so that the compiler knows, okay, I will just stop this move here, and then I will go back and check what I can use instead. And like I said before, we have here a copy constructor, which is normally expecting an L value, but we have this word const here, special made, which can also accept R values. That was our second priority. Then the compiler said, okay, there is something happening. And then I go back to this type and check here the constructors again and sees, oh, I can use here this copy constructor. And then the process can continue. So it is not interrupted anyhow. This is very simplified, right? So careful. I just simplified this for understanding. But I hope you understand the process a little bit, which means you can then not use the move constructor, but you can use then instead the copy constructor and still make the action what you wanted. And what is the difference about a primitive type and a non-primitive type? Answer is a string has, for example, constructors, and a primitive type here has all these constructors not. And the string here is custom provided by a programmer, and the primitive type is not provided by a programmer. It is built in C++ and optimized internally. And yeah, that's so the more or less differences, but of course there are much more, but this is enough that we know. So important here is to note, this is normally provided by a programmer. It is, and it has also constructors like here, probably much more than like here when you jump into the library, but not, we are doing not this, but it has constructors. And constructors means it has probably also a copy constructor and a move constructor. And look what they are trying to do here. They say, I want to use this o.s here, which was passed. I want pass it to this here, to the string. And I know the string has also perhaps a copy constructor, move constructor. And this std move is all time an indicator. Yeah, I want to use move semantics. When you see this one, anyone tries to use move semantics. I say here try because it's not all time possible. and if it's not possible, the compiler will just jump back to the copy constructor. But here they are casting this L value, because here it's still named variable. The compiler will treat this here as an L value. That's why they are using now std_move to cast it to an R value. Now after this here, after this part, the compiler will use this here as an R value, and then they are passing this here to here. So they are from here to here. This S here will be created, passed by an R value, right? From here to here, passed by an R value means the string class is checking the constructors, and the string class will have also a move constructor in it and will call there the move. And this is the part which we can't see here. Okay, but this is so what happens a little bit, not accurate, but let's say so about this one. All right, so we have figured this out. The bad thing is, because normally what we have to do is jump to the string class to see how the move constructor there happens, but we skip this because this is the standard library and it looks a little bit more complicated. In this one we just stay here and we will figure out what happens. Normally what we expect here, what you expect here happens. It is just taking the value of S of the temporary object. What was S? S was created with this default value that was test, and test was taken later here with this one. Again, you see this is all time the same variable. S is taken from here, but it was converted to an R value so that we can again use move semantics here in string and pass this test what we created from this temporary object here again. And what was our goal again? That's also something strange. When we talk so much, we don't see our goal. Okay, our goal was here, when I remember right. We got from here to past it here. So we are still trying to create this A here, right? That was our goal. And this A here, which we try to create pass with the move constructor. And now we are trying to assign the values. You can see this one is assigning the values, okay, of this A. So the AS is this one, and this one here will be assigned there with test, with the move constructor internally. All right. Okay, and let's go to the next line, which is this one, and this looks also not normal. Here we try just to assign K, but we are using again something special, again the standard library, and here the word exchange. And this one I try to make it short. It is just taking the value from our variable O and the member K, which is -1 still, and it is just assigning it here. And this function here is doing one more thing. It says I replace the old value, which means from what we passed here, so the O value K, this one here, which will we take, I replace this one with 0. Okay, this one I skip. I don't skip. I mean, I don't explain it now in detail because we will see it later anyway. And we continue. The next line is this one, and this is just our function body again. Keep in mind, in the function body you can do whatever you want normally. And here I just print out move constructor A called. And one more thing you should keep in mind, move constructors can be optimized out, which means if you do something important here, it will be never called. Perhaps this kind of stuff is never called. So let's go back fast to our place. We were here, and we have created this temporary object. We passed it here to this function, and here we tried to create this A, right? And this A was created by pass by R value, pass by value, and pass by value we have we have two options. We could use move constructor, copy constructor, or the move constructor. The compiler prefers the move constructor if it's available and possible, not all time possible. Here it was possible. Then we have used the move constructor and we learned, okay, we have to be careful here a little bit. And we have just assigned these values there and there. And we learned also the string here was passed also with a move. And I forgot to mention why they are using here this move, because strings can be very big. Here in this example, they have only just word. That's not very big, not very performance. There is no performance loss. But keep in mind, a string can also be, for example, a dictionary. They took out all words about a dictionary, more than, let's say, 10 million words. And then you have here 10 million words, and 10 million words you don't want copy, because then the performance would go down. And that's why you will see most time, if you have a string, they will use std move, because they will try to use the move constructor. This is a very good place to use the move constructor actually when you have big data. Okay, and let's see the output here. So the first was this one. That was this line. Then we have created here this temporary object. That was the constructor call. And from here we passed this temporary object as an R value to the function, and we created here this A, but passed by value creation, and with the move constructor, and here the move constructor is called. So that's enough for this video, and like all time, if you have any questions, write in the comment section. See you in the next video. Bye and good luck.